My dear friends, welcome back to BSpice. In this session, we'll continue with HVAC, wherein we'll focus on controllers. This is the look and feel of the controller. Of course, you know you would have seen many DCS controller, but here we are focusing on HVAC controller. Okay. So, controllers in the sense that we are going to talk about controller-rich action, whether direct or reverse action, and how to identify the reverse or direct action based on application, very important and very critical. And also we'll focus on the controller types, temperature controller, relative humidity controller, enthalpy controllers, and of course the universal controller. And finally, we wind up the session with reset. So what is reset and what is reverse reset and direct reset? All these we'll dive deep into this. Okay. So let's go into the details. Okay. Controllers, just a basic things. As we know, controller receives signals, okay, from the sensor, compares the input with a set of instructions such as set point, right? Throttling range, applies control logic, right? And then produces a output signal. Okay. So the output signal may be transmitted either to the controlled device or to the logic control function. Type of signal from controllers can be electric, electronic, or pneumatic, or digital. So the electronic signal could be either a voltage or current. Voltage output, as you know, maybe 0 to 10 volt DC, 12 to 15 volt DC. Okay, other ranges depending on the controller. Voltage output has a disadvantage. What is that? The voltage are more susceptible to distortion over long wire distances. Current outputs modulate from 4 to 20 milliamp and have an advantage of producing little distortion over long wire distances. So this is about the just intro part, friends. Now we go into the actual. Okay, controller action. All controllers from pneumatic to electronic have an action. Okay, maybe direct or reverse, right? So what is a direct action? So direct action means controller output increases as the sensor input increases. As simple as that. So for example, as the room temperature changes from 70 to 71 degree Fahrenheit, the controller output changes from 10 to 12. Okay, that's it. Very simple, isn't it? So it's a direct action, right? Yeah. Then reverse action. Reverse action is nothing but as the variable like temperature increases, the controller output decreases. For example, here, the temperature rises from 71 to 71. Okay, the controller output decreases. You see here, this decreases from 8.1 to 7.3, something like that. Okay, so that is what the reverse action, which we all know. Okay, the action of the controller must match the proper HVAC application. So that is very important. See, you may be thinking, what is a big thing in direct and reverse? That is okay, meaning okay, but you have to, match the proper HVAC application. For example, normally open heating valve, normally open NO, always use direct acting controller. Okay, right. So that is the point, friends. Now we'll go into the very, very critical aspect of this session. This is one, how to identify the reverse or direct action. Okay. See, just focus on this table, friends. Very, very important. Controller action and the parameters here, right? Based on the action, based on this parameter, like heating, humidification. Just remember this: heating, humidification, and pressure sends downstream from the control device. Then cooling, dehumidification, and pressure sends upstream from control device. Okay. And here you see here, system fails to on, normally open ports, normally close electric contact. System fails to off, normally close port, normally open electric contacts. Okay. So you have a direct action, reverse action, direct action. I'm going to tell you with the example. Okay. But before that, how to use this table. Okay. Just first pick the correct application. Okay, for example, temperature. Okay, just focus. Select heating or cooling. Okay, so heating or cooling. Okay, right. And for humidity, select humidification or dehumidification. And for pressure, select whether the sensor is downstream or the sensor is upstream. Okay, right. So just focus on this. Then once this is done, the second step is to determine how the application fails. For example, does the heat fail to full on or full off? For example, we have taken heat, right? So system fails to on or system fails to off. So this are so both once the both are decided, then we need to correlate this what do you call this tabulation. Okay. For example, correlation means what? This is your column, right? This is your row. So how it correlate? Okay, let's see. Chiller water air conditioning cooling application requires controlling a normally open chilled water valve. So here cooling application, right? So cooling. So this guy, right? Cooling application. And you remember normally open valve. So under normal operation, the chilled water valve is open and as the temperature decreases, the controller signals to close the normally open chilled water valve. So here, you see here, since the valve is normally open, so we need to consider fails to on this guy. Normally open, right? We need to consider this. So the column and row intersect at where? Here, reverse action. So system fails to on and this is the application cooling and reverse action. So this is how we need to identify. Okay, maybe for example, one more example I'll take, right? Then a return air humidity sensor modulates a closed chill water valve for dehumidification. Okay, see, yeah, return air humidity sensor modulates a normally closed chill water valve. So here, normally closed. See here, so system fails to off, we need to consider. Then what is the parameter here? It is a dehumidification, right? So normally off, normally closed, system fails to off, dehumidification, then direct action. So that's it, friends. Very simple. So this is how we need to identify. I hope this is clear. Now we go into the controllers, okay? Controller types. So controller type in the sense temperature controller. Temperature controller, as the name implies, is an instrument used to control temperature. Very simple. So the temperature controller takes an input from a temperature sensor and has an output that is connected to a control element such as a heater or fan. Okay. So the temperature controller typically requires a specific type or category of input sensor. Some have input circuits to accept RTD sensor. Other contain input circuit for thermistor sensor. Okay. So yeah, these are the temperature controllers basically. Yes, friends, right. It's very simple actually. Yeah. Then relative controller. The input circuit for relative humidity controller typically receive the sensed relative humidity signal already converted to a 0 to 10 volt DC or a 4 to 20 milliamps current signal. Okay. So the set point and scales for these controllers are in percent relative humidity. Then we have one important thing, enthalpy controllers. Okay. So enthalpy, one moment, friends. Yeah. Just a moment. So you may have a question, right? What is this enthalpy, right? So enthalpy is a thermodynamic property of a system that represents the total heat content. That's it. Very simple, right? See, enthalpy is particularly useful in processes involving heat transfer and constant pressure, okay, such as chemical reaction. So the point enthalpy is a thermodynamic property of system, okay? Okay, now coming back to the subject. Enthalpy controllers are specialized devices that use specific sensor for inputs. In some cases, the sensor may combine temperature and humidity measurement and convert them into a single voltage to represent enthalpy of the sensed air. So in other cases, individual dry bulb temperature sensor or a separate wet bulb or relative humidity sensor provide inputs and controller calculates the enthalpy. So in typical application, enthalpy controller provides an output signal based on the comparison of two enthalpy measurements, indoor and outdoor, rather than the actual enthalpy value. So that is a basis here. Okay, right, friends. So that is about the enthalpy. Then we have a universal controller. The universal circuit of, the input circuit for universal controller can accept only one can accept one or more of the standard transmitter transducer signal. So the most common input ranges are 0 to 10 volt DC and 4 to 20 milliamps. And of course, other input variations also available like 2 to 10 volt DC and also 0 to 20 milliamp signal. Because these inputs can represent a variety of sense variables such as current like 0 to 15 ampere or pressure 0 to 3000 psi, the setting and scales are often expressed in percentage of full scale only. So basically, this is a universal controller, friends. Okay, right. So now we will go into the reset section. Reset is nothing but is an automatic resetting of a set point based on secondary signal. Okay. So reset of a set point is used for comfort reason, for better control or for save energy. A common example of reset is our hot water reset. So what will happen? Hot water reset automatically decreases the hot water temperature set point as the outside air temperature rises, right? So if the outside air temperature is 0 degree Fahrenheit, the building requires a 180 degree Fahrenheit water, and if the outside temperature is 70 degree, the building requires 90 degree Fahrenheit water. Okay. So as the outside temperature increases, the hot water set point drops. So this is just a simple explanation, friends. So the point to consider here, friends, in a reset application, there are two sensors actually. Just remember this, primary sensor and secondary sensor. Okay. So yeah, in this example, actually, two sensors are used, right? One is outside air temperature, other is the hot water supply, right? So yeah, that is what primary and secondary. Okay. So if you consider this example, hot water temperature is the one which is controlled, right? Therefore, hot water sensor is a primary sensor. So the outside air temperature sensor is a secondary sensor. Okay. So that is the point. The function of secondary sensor, that is outside air temperature sensor, is to reset or automatically change the set point of the controller. Okay. This is the meaning actually. So just remember the hot water reset. Okay. Then very important, how to say reverse reset and what do you call direct reset. Reverse reset means that as a signal from secondary sensor drops, the set point of the controller increases. This is the reverse reset. In the example discussed in the last slide, as the outside temperature drops, the hot water set point rises, right? This is the reversal. Then direct, with the direct reset, as the signal for the secondary input increases, the set point also increases. So direct reset is less common than reverse. For example, this is a summer compensation. That is an example for direct reset. See, you can see here, outside air temperature 72 degree Fahrenheit and zone set point is 72 degree Fahrenheit. Then if it is up 105 degree Fahrenheit, then this zone set point is 78 degree Fahrenheit. So this is just a typical example for summer compensation reset schedule, friends. Okay. So that's all about the controllers, friends. Thanks for watching, and yeah, continue to support our Spice channel. Okay, we'll come out with many more videos. And the next one, I am going to talk about the HVAC. In that, I am going to talk about the digital DDC, digital direct control. Very, very important for this HVAC system. See you then. Take care. Bye-bye.